I'm sure you guys have heard that if you shuffle a deck really well, there's a chance that no one has ever had the deck in the exact same order you have it ever in the history of the universe. And that's because there are so many different permutations of a deck. In fact, it's about 8 times 10 to the 67 power. That's 8 with 67 zeros after it. So if we have two different people shuffling decks really well, what's the probability that they have the deck in the exact same order? It's going to be 1 over this huge number. I was curious, if we're flipping a coin, what is the number of heads in a row that we would need to have for these two events to have the same probability? So that'd be equal to 1/2 to the x. We can rewrite that as 1 over 2 to the x. So step number 1, we can do both sides to the -1 power, giving us this right here. Then we can natural log both sides. On the right-hand side, this x exponent can be brought in front. On the left-hand side, we can split this into two separate logarithms. Log of 8 plus log of 10 to the 67. Then the 8 can change into 2 to the 3. We can bring the 3 in front, and we can bring the 67 in front. Then if we divide both sides by natural log of 2, we now have an exact answer for x. And if we plug all this into a calculator, this is the approximation, about 225.569. So the chances of two people shuffling the exact same deck is about the same as if you flip a coin and get 226 heads in a row. How exciting.